In this video, we're going to discuss IP concepts. Now, if you want to get really technical about it, IP is a layer 3 protocol, and TCP and UDP and all of the other protocols that reside on top of IP are layer 4 protocols. However, most network engineers, when they're talking about an IP network, even though they're referring to the layer 3 protocol where the IP addresses live, they'll actually use the phrase TCP address or TCP IP protocol. A little inside baseball, whenever I was first putting this slide deck together, I actually called it TCP IP concepts, and then I realized, well, I'm not really talking about just TCP IP, I'm talking about IP in general and how IP works at layer 3. Now again, there are many layer 4 protocols that can be used with IP. The most common ones are TCP and UDP. But if you follow the CCNA and the CCNP certification, you'll find some routing protocols that are their own layer 4 protocol. So they run on top of IP, but they don't use TCP or UDP. However, for the CCENT, all you really need to know about is TCP and UDP and their basic differences. The basic difference is that TCP is connection-oriented. You get assured delivery with TCP. And when we talk about how TCP communications work across the network, we'll show you how that assured delivery works. And you also get congestion avoidance, meaning that if I'm flooding my TCP IP connection, there are mechanisms built into TCP to say, hey, slow the rate down some. I don't want you to flood my upload connection because it will negatively impact my download speed. There's also error detection built in to ensure that the data that's transmitted at layer 4 is actually the data that's received at layer 4 on the other end. Now, because of all this assured delivery and congestion avoidance and error detection, TCP is a pretty heavy protocol. Again, when we delve a little bit into how the protocols work, we'll actually pull up Wireshark and we'll show you the difference between a TCP packet and a UDP packet, and you'll see a TCP packet is generally a lot bigger. As a result, TCP is used for applications where you have to make sure all the data got there and got there in the same order as it was sent. These are HTTP connections for web browsers, for example. These are FTP connections because you want to make sure that when you do an FTP transfer, you actually received the entire file and you didn't drop the middle third of the file, for example. And in complete contrast to this, UDP is a connectionless protocol, which means, yes, it's a lot less reliable than TCP. You don't have any of the sequence numbering, you don't have a whole lot of error detection or congestion avoidance. UDP just basically throws the data on the wire. Hey, here's the IP address, I'm throwing it on the wire, hope you got it, because there's no acknowledgement or anything else built into UDP. Again, in contrast to TCP, UDP is a very light protocol, so it's very well suited for things like voice over IP or video streaming. Because the packets are small, for example, and this is getting way advanced from the CCENT, but for example, a voice over IP call using the G711 VoIP codec puts out about 80 packets a second. With UDP, that's pretty simple to do because UDP is pretty light. You don't have to worry about computing checksums and doing all this assured delivery and acknowledgments and all this other stuff like that. It just throws it into a UDP frame and sends it across the network. On the receiving end, again, of talking about the same VoIP call, it doesn't matter if out of this stream of 10 million packets you lost 30. It doesn't really matter because by the time those lost packets got there, well, that's part of the conversation that was 5 seconds ago. I don't need to play that back, so therefore I'm just going to drop it. I'm not going to ask the other end to resend it. I'm not going to do any kind of congestion avoidance or assured delivery or anything like that. But again, this is getting some pretty advanced concepts, but it's good to see the difference between TCP and UDP. TCP is pretty heavy. You know the data gets there. UDP, there is no assurance that the data you sent actually got to its destination. So let's move on and talk about one of the most basic concepts with IP, and that is the IP address. IP addresses are logical addresses that uniquely identify an endpoint. And you recall when we talked about the OSI model that the layer 3 addresses are logical, meaning that you can have an IP address and you can assign it to an Ethernet workstation or a token ring workstation or a workstation running frame relay or a WAN protocol. Doesn't matter because IP addresses are logical. They are 4 octets, 0 through 255 each separated by a dot. For example, an IP address might be 192.168.1.104. Now, at the very nitty-gritty, down where the goats graze, as they say here in the South, each octet is 8 binary bits, and essentially an IP address is a decimal representation of a 32-bit number. Now, we'll talk a little bit about binary subnetting, but you won't really need to learn a whole lot about binary subnetting for the CCENT exam. If you get the CCNA and the CCNP and any other certification, you'll live and breathe binary subnetting. especially when you start to design wide area networks. But for the CCENT, you have to know a little bit about them and how they're put together, but you don't need to know how to actually subnet in binary quite yet. Each IP address has a network and a host portion. There are 5 classes of networks, class A through E, but they're rarely used anymore. And when we talk about IP address classes a little later in the course, you'll see why they're rarely used anymore. Now we use what's called CIDR, or classless interdomain routing. It uses the number of bits in the network portion of the IP address to determine how to route traffic. And if you've seen any network discussions, you'll see, oh, that's a /26 network, or that's a /30 network, or that's a /23 network. That is CIDR routing. And again, when we talk about how IP addresses are put together, you'll see how CIDR blocks are put together, and it'll make a lot more sense. And last but not least, we'll show you this lovely little picture. And this is a graphical representation of a layer 2, a layer 3, and a layer 4 packet. Now you see, at layer 2, it's pretty simple. Receiver address, sender address, how many bytes are in the packet, and the data that's in the packet. This data inside this Ethernet packet, this layer 2 frame, if you will, is IP. You go up to the next level and you've got all the IP bits, and I'm not going to get into all of them here or even in this course. But you've got the sender IP address and the receiver IP address. And then you have the data inside the IP packet. The data inside the IP packet is the TCP or UDP or so on and so forth. Sender port number, receiver port number, acknowledgement number, so on and so forth. And again, if you were to look inside this TCP packet, you'd see information about the layer 5 and higher protocols inside the data payload in the TCP packet. And again, when we pull up Wireshark and you actually see these concepts spelled out for you, it'll make a lot more sense. But this is just kind of a preview of what's coming elsewhere in the course. And that concludes our discussion of IP concepts.